Hello and welcome to this little video. So what I want to show you today is the C programming course I'm currently working on. So my name is Toby and I do work as a staff member at the University of Applied Science in Furtwangen, Germany. And while I do work at a business um, department, so we are business informatics degree. I have absolutely no like tangent with business. I have no idea about that. I also don't want to have any connection points really with it. I'm a programmer and not a business guy. And so last semester, actually, I think 2 semesters ago, I asked whether I can teach C programming to the people, which isn't really something you need in in the business world probably, but if you want to be a programmer, I think C is a very important language. It's, I think, actually the most important language. Um, right. And so I thought, hey, let's make a C programming course. And it isn't taught yet. That's why I'm still working on it. But at least I'm told there is the possibility of me um, being allowed to give that lecture. And while I don't know if that's actually the case or if it ever will be the case, um, I'm still working on it because that's part of my work time and I don't know, that's fun, and so I'm working on it. Um, so I want to show you a bit what we do in the course, and I give you like a 2 or 3 minute heads up now about how the course would be structured, like how it would be taught. Um, well, first of all, the why the course is taught. Um, so my big problem with programming and how it is taught in universities, it is that it's missing a very important component, and I've made a way too long video about that, and people didn't like the video. Well, um, so the thing is, if you're at a real university, so like the non-applied science university, you probably have your very theoretical courses where you learn your big O notation and all that stuff. And I mean, you have that at applied universities as well, but yeah, so that's a very theoretical part. And I don't say that's not important, but uh, it doesn't really give you experience in writing a program. Okay, so then there's the second kind of lecture, which basically is um, what's happening here. Oh, okay, I just saw a weird scene here in the simulation. So the second type of lecture is basically your Java 101 course, where you're doing like, hey, okay, today we learn about lists. This is a list. Let's use the list. And then next week, hey, look, today we learn about hash maps. This is a hash map. Let's use a hash map. And then the week afterwards, this is a database connection, right? You can open the database connection with whatever, and then you can talk to the database, and then you close the database connection again. And well, it's basically a lot of topics, but they are just not linked to each other in any way. It's just, hey, look, here's a series of topics. And I don't know, well, you learn the topics, but you don't really incorporate them in anything. So you just hear about them and then, well, that's it. And I don't like that. Then there's the third type of lecture, which, well, it's not a lecture, but basically it says, hey, you are allowed to write a program and you get 1 semester time for it, and at the end you get a grade. So, which is great for the student or the students. That's probably some group work thing. That's great for them because it's really fun to work on your freely chosen project. But in the end, it's still missing the person with experience, right? If you are a beginner and everyone else is a beginner, really, yeah, your program is probably very slow and you don't know where it's going and you don't know what you're actually doing. And so I wanted to have a course where this is not the case, where you basically have an already planned out project, which in that case would be this thingy here you see on the screen, although it's not finished, where you have a planned out program and it is created like together with the lecturer, which in that case would be me. So there would be a part of it that's programmed by the lecturer, then a part of it kind of programmed together, so more or less interactively between the lecturer and the students, and then there would be parts for the students to do on their own, or well, as a group work, I don't know, but like without the lecturer essentially. And yeah, this is how the course would be, and I think that's actually a nice thing. Although many people, at least several people I have talked to, don't quite like the idea of watching other people code. I think it's an essential skill, or well, not an essential skill, but an essential thing to do. And I had a course like that myself, and it was the best course I ever had. And well, given that this would be a voluntary course, I don't really see a problem in it because you can just choose to not choose the course, right? Um, okay, so that's a bit talking about the program, more about, well, no, not, there was a bit of talking about the course where we would write the program. Now comes the talk about the program. So, as you see, it's a little bit slow at the moment. That's because the rendering here is super slow. But I can speed it up a bit. Let me just, so now it's faster, but it's a bit sloppy because the animations are now too fast for them to be seen correctly. So let's just put it on slow mode again. It doesn't really matter for now. So in the course, like I said, a big chunk of the course would actually be done by the lecturer, or at least shared between the lecturer and the students. And so it is not that difficult as it might look at first sight, which doesn't mean it's easy. It's still a difficult course and probably too difficult for many of the students. But again, it would be a voluntary course, and therefore you can just choose to not choose it if it's too difficult for you or you're not interested in such stuff. Okay, so the way how the stuff here works is we are obviously not talking directly to the operating system, so there's a little library in between, which is called SDL2, and I don't know, maybe you can Google that, it's really cool, which does the operating system interaction, which is mainly done because I have no idea about any system that is not Windows. And so it is able to talk to the camera, and not to the camera, sorry, to the screen, to let you draw the pixels, and it's also able to get the mouse and keyboard input, and theoretically also it can talk to your speakers to have audio output, which at the moment isn't in the simulation. This is not a game, sorry, this is a simulation. To the simulation, and maybe at one point it will be added, but not at the moment. Okay, so that is right. We don't do the really complicated stuff and talk to the operating system. We talk to the library. And actually, there's another layer between the library and the student's code to make that stuff even more simple. So essentially, you start by, hey, this is a two-dimensional array of colors, and you just have to set the colors, and like what you see is the two-dimensional array of colors, and you just set at which position you want to have which color. So essentially, it's really not difficult. And so during the different weeks or over the course of the different weeks, what we would learn is we would start with drawing simple shapes. So we can draw a rectangle and a circle, and then afterwards maybe even the outline of a circle, which is more difficult. And then what would be really super difficult would be an arbitrary line from point A to point B, which would probably not be done by everyone, but I don't know. Let's see. I will see how it goes if it's ever done. Okay, so we have that. So afterwards, instead of drawing arbitrary rectangles, we draw this grid here. So we have tiles in a grid, and then we would obviously have some sort of 2D array that stores if on a specific position there's grass or street or mountain. The pink stuff is kind of undefined. If we have that, and then we have that's the wrong one, sorry, this key. Then we have an editor, and you can basically place streets, and you can erase them again, and you can place mountains as well and erase them, right? We can save that data and we can load that data. It's not difficult. It's quite simple. You basically say write this array, and then later on you say read this array, and that's about it. Right, we have that, and then afterwards you introduce the concept of people. So you have like people, but they start as circles and they move like tile by tile, and then that gets changed to them moving continuously, so basically pixel by pixel. And afterwards we learn how to read sprites. So that is also, again, it's not very difficult. It's basically you have a big file with all the sprites in there. This is actually just a little disclaimer, the sprites aren't by myself. They are from a game called Knights and Merchants, which is a game from like 1998 or something. And right, so all the sprites come in one big file, and essentially how it works is it says this is the width of the sprite, this is the height of the sprite, and then you get the 2D array of the colors, and then you read that, and then you read the next sprite. Again, really not difficult actually reading those sprites. And then we will take those sprites and put them into animations. And with the animations, we will then change the persons from being circles to actually using those animations. And probably the next thing then is adding pathfinding, so the people will actually find a path and then they follow the path. And as you see now, they don't just follow the path, but they interact with each other. So like they wait for others and then they exchange their position with others. The system isn't perfect, but it works. Although sometimes it will lead to stalls, right? It's not quite done yet, I have to say. Right, we have that. Then we have the buildings in here, and at the beginning, the buildings are operated without persons. Unlike now we have a person in the building. But at the beginning, the buildings are basically, yeah, that they act on themselves or on their own, and they will produce the stuff. And if they have produced something, someone has to take the produced resource and bring it back to the storehouse where it belongs. And later on, like I said, we now actually have people working in there, and we have, at least for the carpenter here, he actually not only creates something, but he also needs something. So he needs a tree to actually work on. So someone has to bring him the tree. And so you essentially have kind of a job system where yeah, well, where jobs are generated, and the people here now have to execute those jobs. So they will look like, is there a job open? Oh yeah, okay, I will just do that job. And yeah, this is quite nice, and it's quite cool to implement. And essentially, how it is done at the moment is the people will use a sort of a state machine, although you don't have to imagine the graphic-y state machines, but it's basically a big switch statement. And um, so if you like in a thing called move to, or the bring resource to building, then the bring resource to building has 7 steps or something, and then there's just a big switch statement of those 7 steps, and depending on in which step you are, you do stuff, and then if you have finished that stage, like reaching the house where you want to go to, you just enter the next state. And like I said, that is done with several switch statements. So you have one switch for each different type of job, essentially. Again, it's not as difficult system. It's not difficult to understand. It's probably not how other people would do it. So you would probably go crazy with object-oriented stuff and make everything its own class and whatnot. And we're not really doing that here. So the whole idea of this course is, first of all, you learn the programming language C. Second of all, you can do not non-object-oriented programming, and that also works. And right, so the whole thing is kind of, we're doing stuff differently than you traditionally learn, and afterwards you at least know 2 different approaches to programming, and then you can choose for yourself if you think object-oriented programming is the best thing, which maybe you decide on, or maybe you say, hey, the other way is maybe nicer or not. Or, so there's different points in there where we say we do it differently, then you probably know it. And so, right, we're doing the, yeah, right. So at one point that fits the topic at the moment. At one point we added this UI system. So the UI system isn't built yourself, but is provided. And this UI system also doesn't work like the traditional UI systems most people know, where you create a thing and then you create a button and then you create a layout and you have to add it and whatnot. And this thing here works different. It's called an immediate mode GUI, which probably other game people know, because like game engines have that. And it works, like I said, it works differently than the traditional UI systems. Again, with the point of, hey, there are things that can be done differently than you know. So that's kind of a big part of the course. So since I now talked about the GUI, right, we can here select buildings or people, and then like they're here, and we can, I don't know how this is called, like basically have a drop-down menu with all the values such a person has, and then you like, then nested in between we have even more drop-down menus. That this guy, his job is now he delivers something to a house. We can see where is the house. It's here, x4 y3 0 1 2 3 4 0 1 2 3. So this is the position where he's going to, and he's transporting timber. And in his job, like he's in job stage 1, like I said, with the big switch statement, he's now in stage 1, which is going to the house. Now he will enter the house, which is the next state. And now he will probably wait inside the house. Yeah, those are actually 2 states. And the same goes for leaving the house. And now he's idle again, right? He has no job, and he's doing nothing. And at one point he will find a new job, and then you see that. Okay, so this is the UI system. Like I said, the UI itself isn't programmed by us, but like having the drop down, like using it, so having the drop down and having the nested other values is done by us. So now here we can, for example, see what resources are in the storehouse. Okay. Something that is kind of related to a thing we did beforehand is I can also say here highlight pathing data, and now I see where the person is going, where black means this is the goal, and the redder it gets, the farther you are away. And super red basically means this is infinitely far away because either you haven't checked the position or you, well, you can't even go there, like inside buildings, you can't go there. So that was one of the other things. Can I? Okay, that was the correct button to get rid of it again. That's most of what I can show you. For example, here you see how the persons are like doing the traffic system. So you see like this person here is kind of reserving this tile so no one can go there. And so that is that blue system. And I see there's actually problems and oh no. So this was the most horrible system to build. It had so many edge cases. And as you can see now, like I haven't figured out all the edge cases, it seems. Okay, but like the system also allowed me to push people out of the way and stuff. Oh yeah, okay. I know what the other things to show you. Um, this one. Sorry. First of all, we can obviously build stuff, so we can now, I don't know, build a new building. Can I speed up the game? So maybe at one point the game will actually crash because one of the storehouses runs out of resources. So the laborers now have started building streets and this building here, and the serfs now have to provide stones to them. So this is again part of the job system. So that's also why we don't implement all the buildings from the game where the sprites are from, because like after 2 or 3 buildings and the street building and stuff, you basically know how everything else works. So at one point, there's basically uh, the point where I say, okay, now we have made enough of the buildings and enough of that. Here's just all the other buildings. So one guy had to shovel each of these tiles off the building to kind of prepare it for building. And now we have to wait until the street is finished, and only after that will the serfs now bring, wait for it. Okay, now it's done. Now they can actually bring resources to the house, and then we can start building there. So normally in the original game, you can start building right when the first resource is there, but here we have to wait until all the resources are there, which is now. And also normally many people can work on it, but here only one can, but I'm okay with that. So as you see, the building gets built, and this is, it looks like a super difficult animation thingy, and it's actually just 4 images that are laid on top of each other in a cool and fancy way. So basically 2 images say where to show stuff, which stuff to show, and the other ones to show like how the finished done looks like. So okay, we can see the people now building the stuff, and it's a bit slow. Like I said, originally everyone would work on the house, so unfortunately you just have to watch. And I actually don't know if I add the building at the end to the other buildings. I think I do now. In the past, I think when the building was done, the game basically crashed. No, okay, so it is done. Okay, like stuff in the traffic system here got messed up. Oh no. Yeah, oh no. Okay, so like I said, the traffic system was a difficult thing, and I have to look at it again, and I knew that already, but I didn't actually know before this video that it was so bad. Um, However, we have that. We have now, we can build buildings, like you saw, and all those things. Another system, which you can't quite see now. So, something I think is important to learn is basically everyone, I think, learns your whatever Dijkstra or A-star, whatever pathfinding algorithm. But people often don't really realize that you can use it for more than just distances. And what we do now is that we actually consider more than just a distance to form our pathfinding decisions. So if I press F8, you see that like you see everything in black except for the street tiles where people have to wait a lot. So every time people wait a big amount of time, or well, any amount of time, they will save that. And so you see like the streets are getting quite red because these are the tiles where people have to wait, right? The people don't just walk through each other, so they always have to wait a bit until they can walk. And if I just add some streets here, then the bottom part is now actually shorter, and we can now watch the people going over the shorter path, but at one point they will realize, hey, we collide into each other so often here, right, that some people just move on top. So the visualization is a bit bad, so we don't really see it that much, it seems. But you get the idea, everyone is walking at the bottom, but sometimes they're like, oh wait, there's so much waiting, I just go at the top. So those paths are almost the same length, that's why we don't even see much of the weight. So it looks like all is black, but it actually is a little bit of red if I look better. So maybe I should just increase the strength of the reddening, maybe. But yeah, there's a bit of red down here, and that's why people go upwards. I'm not sure if the system is actually good, how it is at the moment, but the idea is there. So you consider more than just the position, but also some other data. That was like I said, it's not quite done. So what we will do in the future, or what I will add in the future is, so at the very end, we will add audio. So you have like music and sounds in the game. One big point that will be added, I think it's the last big point, is a genetic algorithm. So we kind of at one point want to optimize the the job fulfillment. I don't know how to call it. So we optimize which jobs which serve or which person will do. So at the moment the people will just take the next job there is in the list if they have nothing to do, and we want to optimize that. So instead of taking just the next one, maybe you take the closest job to you, or you take the most important job. However, what is an important job? And so we will define some things that could determine the order in which we take the jobs out, and then we will kind of optimize that via a genetic algorithm, which again sounds way more complicated than it actually is. However, if you have added all the things that are needed, it isn't that difficult. So now actually something has happened, and if this would have not happened, I would have forgotten about it. So the game just crashed, and it wasn't a big crash. It was basically like you see here, in one of the stores. So in order to have the serfs running around a lot, I just created a bunch of dummy jobs. And what happened now is that one of the storehouses ran out of resources. So the jobs basically are bring stone from this storehouse to the other, and then bring I don't know, trees, I think, from the other storehouse to the first one. So, and at one point, one of the storehouses actually runs out of resources. So now the game crashed, and now what is very important, when I just restart the game, and let's speed up things. When I restart the game now, it will actually replay all the actions I did before. So if you watch for a while, you will see that in this area where I placed the sawmill in the last run, the sawmill will be built, and you will also see that I select some of the build. No, I do not. Wait. But the thing, what? Okay, in theory that should happen. I just changed something in that system like a few minutes ago, just before the video. And maybe it's ignoring that now. This is the typical, but it worked last time. Oh, sorry, the game was still running. I can't compile. And no, for some reason it doesn't work anymore. So okay, it seems like I've broken it. I really can't tell you why though. So normally, as I said, you really have to take my word for it. We have a system in place that when you have a crash, creates a file, and here actually is the file. And next time you play, it will load that file and will replay the exact same actions to do the exact same thing again. Like I said, I really don't know why it doesn't work at the moment. I just know that I did something with it a few minutes before I started the recording. So probably that is the reason, and I haven't checked it then. Right. Oh no. So, however, there's one thing still left that I want to show you, and I know that that works. No, give me, can I? Thanks. So one system I really love is the following. So I have the game now running on the right side, and I have the code on the left side. And for example, it's a very simple thing, but just to see what I mean. While running the game, I can actually say I changed the code, so I changed now the rendering color of the grass, which was green, to orange. And now I just recompile the game. And as you see now, it just changed the color to orange, but like the game kept running. It didn't restart, it didn't do anything. We just reloaded the whole thing. But like with a different program. So we can change that even back to green because orange is a bit weird. And yeah, so nothing bad happens when I do that, which is quite cool. And let me just, I mean, that was kind of a cheap thing and didn't really help you. But what I realized earlier on, if it's, no, wait, that's probably not the correct person to do that. So let me just pause the game. I want to pause the game because I want to show you the path. So as I've described before, you have black is the goal, and like the redder it gets, the further you are away from the goal. And I thought, wait, wouldn't it be way more sensible to have everything that I haven't checked at all in a completely different color, and so I can basically just do that. Wait, so here is the highlighting code of the pathfinding data. And if I now say, okay, if, sorry, if at a specific position, the pathing is invalid, which is basically my way of saying either I can't go there or I just haven't checked there. I do something completely different, which is I render the whole thing in blue. And so again, I recall this takes a bit of time, but that is mainly because I'm recording, and that takes my CPU a bit of time. Hello? Oh, sorry. So since the game was paused, it didn't get re-rendered. I just wanted to pause it for the thing to not go away, right? And now it looks way better because I really see, okay, this is the part that has been checked, and the blue part is totally separate from that. And yeah, like I said, normally there's a replay system in there, and I don't know at all why it doesn't work anymore. But maybe you still thought what I'm doing is interesting. So at the moment, we're talking about around 5,000 lines of code, which is kind of 500 lines per week. I don't know if people think that's interesting, but yeah, 500 lines per week. But as I said, a big part of it is written by the lecturer, which is me, either the lecturer or as a joint thing between lecturer and students. So it's not like the students have to come up with 500 lines of code, but it's more like, I don't know, maybe 100 to 200 is left for the students per week. And even if they don't do the tasks they are given, like they will be given the solution of the tasks as code form, and maybe even as a video form where I would describe the solution and how to implement that. and so on. So this was my program. I have talked way too long about it, I think. If you have watched it, thank you for that. Maybe put your questions um, in the comments, and well, until the next video, I guess. Again, thanks for watching this video. Goodbye and have a nice day. Hello again. Sorry, I just fixed the error. It was a little thing. Wait, let me just speed up the game. And I don't know, I move around a bit. Select the stir house and select the sawmill. And now I will actually build some stuff here. And now I save it and exit. And now I restart, and the same thing will happen again, right? I'm not doing anything. Oh, right, I can, so the speed up is separated from the replay, so I can speed up. And I can even choose to not speed it up anymore after a while, which is now, right, as you saw, I just selected the storehouse and the sawmill, and now I'm building that line. And what will happen in a few seconds is when the replay runs out of actions, which is now, I will automatically trigger a breakpoint in my program, because if that got, like, if the replay got saved due to a bug, that means this is now the last frame. Well, this is the frame in which the bug will occur, so I can now like step through it. Right. So the thing, yeah, it was related to me fixing a bug earlier and therefore breaking it in a different way. Yay. So okay, that was just what I wanted to add here. I hope you can live with that 2-minute edition of the video. Right, again, as I said before, thank you for watching the video if you have actually watched it. And you can leave comments, you can even... Is there still the possibility of doing thumbs down? I think there is, it's just that you can't see it, only I can see it or something. I don't mind, just put your opinion underneath it, and have a nice day. Goodbye.